Hello and welcome to this video talking about holes in rational functions. This video will talk about the nature of a hole in terms of rational function, how to find it. It will also talk about vertical asymptotes, which you already should have an understanding of in terms of rational functions. There's somewhat of a commonality between holes and rational functions, and there's some differences as well, so you need to see them next to each other to kind of file them in the right places in your brain as you learn them. So let's get started and talk about holes. First and foremost, a hole is a form of discontinuity in a function. Okay, it's a place where a function loses its connectedness, if you will. So it will occur if a value of x makes the numerator and the denominator of a rational function equal to 0. Okay? Now you can probably see a little bit how they're related already, because it being a hole in a vertical asymptote, we talked about if a denominator is made 0 by a value of x, you get a vertical asymptote. But here, it's not actually going to be a vertical asymptote because we're talking the numerator and the denominator are 0, and this is what creates a hole in the function. Okay, let's start to examine that a little bit with a couple of examples to play with here. And I'm going to talk about y equals x plus 3 over y equals x plus 3 over x plus 4. So something should jump out at you very quickly here, that this number of x in the denominator, this value of x, would be -4 to make the denominator 0. And if you notice, when I put that in on top, it actually makes the numerator equal to 7. More importantly, it's not equal to 0. So this is an example of no hole. Okay? Not even kind of worth stating. It's really a vertical asymptote. And the equation of that vertical asymptote would be x equals 4. Okay? Excuse me, x equals -4. So there's a place where there's a denominator is equal to 0 by plugging in -4, but not the numerator. So it's not a hole. Let's look at this next example here on the right. F of x equals x squared minus 9, all divided by x minus 3. Well, quite quickly, it should jump out at you that an x value of 3 will make the denominator equal to 0. And then if you notice, if I take a look and examine that value plugged into the top, I am in fact getting 0, because 9 minus 9 is 0. So again, the numerator and the denominator are made to be 0 with that value. So this will have a hole. Okay? Now I haven't said exactly where yet. I'm just saying that you know it will have a hole by the fact of when an x value makes the numerator and denominator of a rational function equal to 0, you will get a hole. Okay? So let's talk about what a hole is a little bit more, or actually steps for finding a hole. And we will do this in very color-coded fashion so that you will have a sense of what I'm writing and what I'm speaking about. Now, very analytical idea. I'm trying to give you some very mechanical steps. Don't get bogged down in the mechanics. Again, you want to have that sense of where is the function's numerator and denominator simultaneously 0. Okay? So, step 1, find all values that make the denominator equal to 0. Not all of these will form holes, though. Step 2, see if any of these values make the numerator equal to 0 as well. Note the values that do. These values will be the ones that will create holes. Step 3, simplify the rational expression. Factor if necessary. Okay? Step 4, evaluate the simplified expression for any values that create holes to find the y values. Step 5, write the ordered pair of the hole. Okay? Now, you got to realize that a hole is an empty point. It's an ordered pair. It is an x comma y. It is empty. So when you graph it with an open circle, just like you did with inequalities. Filled circle in on a graph means that there's actually something there. But this is how we represent a hole. Okay? It is an ordered pair. Finding the x part is very easy. I'll tell you where I see students fall down is finding the y part. Okay? Now if you ask yourself why, is because you're finding an x value that makes the denominator equal to 0. Well, that makes the function undefined. So when you go to plug that value in, you don't get anything out. So how are we going to find this missing value, this undefined value? It's kind of cool if you think about it. That's going to happen right here in steps 3 and 4. Okay? And it's something that we talk about. It's a process of kind of filling in the hole, mathematicians say. Okay, so let's take a quick look at this non-example I have here just to give you an idea what these look like graphically. Okay? So we'll look to see if there's any holes in this function of y equals x plus 3 all divided by x minus 4. You see x minus 4 is equal to 0 when x is 4, and that value of 4 plugged into the top does not make 0 because it's equal to 7. Okay? So what we have here is x equals 4 is a vertical asymptote, and there's no hole in this function. Okay? So if I showed you the graph, which I just happen to have cooked up here, you'd see exactly that. There's more points obviously to find and investigate other parts of the graph. But the one thing you need to see here is that you are in fact getting this vertical asymptote through 4 on the graph. Okay? So let's go into some examples that actually have holes now. Okay, so step 1, I'll do in red. Find all the values that make the denominator equal to 0. Well, you see here I have f of x equals x minus 3 over x minus 3 times x minus 5. So I'll set the denominator equal to 0. Now, some people here, not a great algebra skill, if you're thinking this, don't FOIL this out, okay, and start to solve it. If you do, you got to do the quadratic formula. Go right to the zero product property, which you should be a pro at by now. X minus 3 equals 0, x minus 5 equals 0. So x is 3 and x equals 5. These are the two values that make the denominator equal to 0. So step 2 is see if any of these values make the numerator 0. Well, when I plug 3 in here, I see that 3 minus 3 equals 0. This will create a hole. And if you see I plug my 5 in, I get 5 minus 3 is equal to 2, which is not equal to 0. This creates a vertical asymptote. Okay? So again, where are we going to find the hole? You're kind of halfway there because you know the x value. Okay? But again, here's the crazy thing. If I went to plug in this 3, I would get 3 minus 3 on top, 0 times negative 2 on bottom, which is just 0 over 0, which isn't going to tell you anything. So you can't just do that. So here's the deal in purple that's really going to help. Simplify the rational expression. This actually will fill in the hole. Okay? So if you notice, there's a way I could sort of say this, is that the problem factor, if you will, when you look at the function, it's pretty obvious. It's the x minus 3 factor that's in the top and the bottom. So here we go. I'm just going to simplify that expression because x minus 3 divided by x minus 3 is equal to 1. So now the new expression, which I'll write as y, equals 1 over x minus 5, will act exactly like the original function, except it won't have the hole in it, because by canceling those factors, I filled it in. Okay? So now, we'll see in orange where it says evaluate the simplified expression, which is right here, okay, for any values that create holes to find the y values. So now I'll use a combination of the purple and the orange so you could see it. But I've got y equals 1 over 3 minus 5. Again, why 3? Because 3 was the value that we said was going to create the hole. Okay? So continuing on, I'm going to get what? 1 over negative 2, which is negative 0.5. So, last final step. I'm writing the ordered pair for the hole. It's 3 comma negative 0.5. If you were asked to graph it, you would find it right about here on the graph. And I actually have this graph cooked up. It's not part of the problem. It's just to help illustrate this a little bit more clearly to you. And voila. So you see, even if I erase the hole that I made there, the graphing software actually made quite a nice hole right in the right spot. Okay? Now, the other piece of this that I want you to see is, don't forget, this value of 5 also made the denominator equal to 0, but you're not getting a hole at 5. You're getting an asymptote. Again, they're both discontinuities. There's no function here when you plug in 5, and there's no function here when you plug in 3. It's just that the type of discontinuity is different. Okay? Continuing on, let's take a look here at f of x equals x squared minus 4x, all divided by x squared minus x minus 12. So it says find all values that make the denominator equal to 0. I'll just cheat in my writing there a little bit, which isn't really cheating. I'll set the denominator equal to 0. And I have to solve that. Well, it's quadratic. Okay, no big deal. I've got skills for that. My first attempt is I'm going to factor it. And one of the factors, 12, that make 1 if I get the signs right. That sounds like 4 and 3. You should be pretty good at that skill. I'll go with negative 4 here and positive 3 here, because I need to get a negative in the middle, so I'll make the bigger factor negative. Okay, equals to 0. 0 product property. Real quickly, you could probably see the answers. X equals 4 and x equals negative 3. Okay, well, they will make the denominator 0. Now, I'll just take a look and see if these values make the numerator 0. Well, for 4, it'll be 4 squared minus 4 times 4, and that's 16 minus 16 is 0. That will create a hole. If I take a look at my negative 3 squared minus 4 times negative 3, you probably know already that 9 plus 12 is not 0. That will create a vertical asymptote. Okay? The vertical asymptote's equation is already done, because when you make the equation of a line, you only need the one variable. But for a hole, you need to find the x and the y value, so we have to continue on. Okay? So, a little trickier here. It says simplify the rational expression, factor if necessary. Well, if you notice, I already factored the bottom. So let me factor the top and rewrite the expression. If you notice, the top, the numerator, can be factored with the greatest common factor of x. So x times x minus 4 over x minus 4 times x plus 3, those two quantities. Okay, well, good news, I have matching factors, so I can actually simplify them. And it shouldn't be a shock, because you have to kind of have these identical factors to get that whole. You can see it was a problem factor where x being 4 is now canceled. So now I've got that y equals to x over the quantity x plus 3. And I know the value that's going to make the whole. It's this 4 value. So all it's going to do is plug it in, okay, and see what I get. I get y equals 4 over 4 plus 3, which is 4/7, okay, which is a little more than half, right? So now I know that my whole value is going to be 4, comma, 4/7. So if I were to graph that, a little touchy. Again, you're not being asked to graph. I'm just using the graph to illustrate it. You might be asked to graph in the future. We'd be at 4 and a little less than a half. And it's a little tough to make a hole there. Okay? If you notice, I actually have the rest of the graph made here via the computer. And it's exactly where we said. Also note that you have a vertical asymptote in this problem, which made sense because this value of negative 3 created a 0 in the denominator, but not the numerator. So right at x equals negative 3, you had gotten a vertical asymptote. Now, there's not, in these examples I did, I hope you realize, there's no guarantee you're going to get a hole and an asymptote. The first non-example I did, you only got an asymptote, okay? You didn't get a hole, and then here you got a hole and an asymptote. The next example, you got a hole and an asymptote. It doesn't always happen. that way. You actually can get a hole in no asymptotes. You can get multiple holes. But again, it all revolves around this idea of finding values that make the numerator and the denominator equal to 0. Okay? So the real magic in terms of finding that y value, though, is right here. Being able to simplify out the problem factor and then build a new expression, which is here, that can be evaluated for the whole value. Okay? And you can tell just by looking at this expression here in purple that when I plug 4 into it, it's not going to cause a problem. But I hope you see that over here, left as it was, plugging 4 in there is not going to work. So again, it's kind of like filling in the hole is how mathematicians call it. So I hope this was a help, and practice hard, do your best, and pass it along to whomever you feel might need it.